Hello everyone, I am teacher Xia Zhou. The product I will unpack and evaluate for you today is the Raspberry Pi version of Transpot ROS educational robot. It is a tracked intelligent robot equipped with Raspberry Pi 4B motherboard, laser radar, high-definition camera, depth camera and other high-performance hardware configurations. It can realize robot motion control, remote communication, map building and navigation, following obstacle avoidance, automatic driving and other functions, and it is also equipped with ROS course video demonstration. Now let's just open it up and see what's inside. First of all, its appearance is packed in an aviation aluminum box, which is very strong. Then there is a thick protective film like this inside, a foam pad. It can act as a shock absorber and sunscreen. Now, let's get all the accessories out. Here are all the parts we took out of the box. The overall content is very rich, and we will introduce it to you one by one. First of all, here is a bilingual manual in Chinese and English, which contains assembly steps, usage steps, and a list of spare parts. It has a robotic arm, depth camera, 7-inch screen. Of course, there are many other configurations to choose from. Here is a checkerboard, the back is a checkerboard, and the front is a QR code, which can be used for AR recognition in the case. Here is the card reader and the memory card. This memory card has been burned into the image in advance, and it can be used after assembly. This is a Raspberry Pi 4B, 8G motherboard. Of course, it is also possible to use 4G. This is the connection line of the motherboard, free guarantee certificate. Here is a depth camera, and its overall packaging is very luxurious. The outside is sealed with a plastic film. It can complete 3D mapping and navigation, viewpoint cloud map, and other related functions. This is a 7-inch screen that can be assembled on the car to facilitate case debugging during actual use. This is a Lidar. This can be used in navigation, mapping, and other cases. Here are some spare parts, and here are the screws. These are copper posts and accessories like screwdrivers. This is the robotic arm. The robotic arm is assembled when it leaves the factory. Then you can directly assemble the entire robotic arm to the front part of the car. This is an expansion board. And then there's a line of tape. This is the battery and the battery box. The weight of this battery is very sufficient. There are 6 battery packs on it. Here is a handle, and a bracket for the handle. This is the overall frame of the car, and it is assembled like this when it leaves the factory. You only need to assemble the expansion board, main board, depth camera, Lidar, and other spare parts on it, and you can use it directly. Now we start to assemble. It looks like this when it is assembled. I can turn around and show you the 7-inch screen above. If you think it will hinder it during driving, you can also disassemble it. It is fixed by screws and is a detachable structure, including the front mechanical arm. If you think it blocks the camera's line of sight, it can also be disassembled. Its disassembly method is very simple. It is fixed by this structural part. Now let's try to turn it on remotely. You can use the handle for remote control. This handle is included inside, or you can use the mobile phone app to remotely control it. Now we can start the remote control. Turn on the switch of the handle, then press the star button. Now you can directly control. First, let's control its mechanical arm. Controls are very responsive. In addition to this robotic arm, it can also control its motor movement. Now turn to the tail. Let me show you this lantern in the back. The light strip can be controlled by the handle on it. There are many modes to choose from. The gimbal of this depth camera can also be controlled. Our handle experience is over. Now let's try the mobile app remote control. The mobile app is controlled through the local area network. We first need to connect to the transport hotspot. Open the Yahboom Robot app after connecting. Click the search device to connect directly, and its control method is also very simple and convenient. Here is the control interface. The control function is the same as the handle control just now. This side is the camera gimbal that controls our Bish Hongguan, and the other side is a motor that controls it. You can also switch the speed and choose his gravity button and joystick. This side controls the robotic arm. Let's go back to the previous page. In addition to the remote control, there are many functions on it, and it can also control the colorful lights, image beautification, Lidar, AR world, intelligent tracking, intelligent patrol, automatic driving and other functions. Now let's experience them one by one. The colorful car light is the light bar at the rear, which can control the color of the light separately. You can also control its color and brightness through this slider. You can also choose the corresponding mode. Control the speed of this mode. The next one is image beautification. Here is to use OpenCV to process the image. Here is the original image, and here is the processed image. In addition to this mode, you can also choose the dynamic mode. There is also a save button here. After clicking this button, the image will be saved in the phone album. Next is the Lidar. This part of the function needs to put it on the ground to demonstrate to everyone. After putting it on the ground, now we start the obstacle avoidance mode. I have cleared the obstacles around the car. Now let's test the radar tracking. I go forward and it goes back. I go back and it goes forward. I turn, and it turns with me. As long as it works within its radar detection angle, it will track. There is also a function here, called Radar Guard. It will sound when it detects an obstacle ahead, and at the same time it will follow the obstacle ahead. There are 3 sliding function bars on the control interface of the app. You can adjust the relevant data according to your actual environment. The first is the detection distance of the radar, the second is the detection angle of the radar, and the third is the driving speed of the car. Now we are going to do a visual demonstration, and I've taken the arm apart, because it might block the view of the camera. Now we enter the world of AR. There is a lot of option boxes here, and there is a checkerboard paper attached. Click a corresponding option box, and a corresponding image will appear on the checkerboard. This image will have a fixed position on this paper. Now, a parallelogram, triangles, circles, arrows, a sword, a windmill, a ping-pong table. Then the following images are all 3-dimensional images. Parallel bars, 2 little people, a table, a chair. This is the AR world. Next, smart tracking. Here are some objects that can be tracked by color. Here I can show you how to track objects of this color. And here you can click a reselect. Then the first one picks the color first, and puts the object we need to track in its color box. Click to confirm the color, and it will be recognized. Now click the play switch to start smart tracking, and the camera gimbal will track this green object. This is a tracking effect of the camera. Other colors can be used besides green. It is because it has a color tracking here. As long as it can obtain the color, it can be tracked. For example, I change a spherical object now. Now it's orange. Let's pick the color again. After confirming the color, it will be recognized. Click the play switch. This is color tracking, an actual effect of smart tracking. Now let's try Smart Patrol. Here are several graphics of different shapes. After we click on it, the transport will move according to the above graphics, and there are 2 zoom ratios of angular velocity and speed limit below. Let's try a circle first. You can see that it draws a circle around the ground, and other rectangles, quadrilaterals, and squares have the same effect by analogy. Next, let's look at autonomous driving. Let's paste the map first. Autopilot now. First, choose the color. Control the car into this box. Now that's okay, and click to confirm the color. Start autopilot. This is the actual effect of automatic driving. Of course, the runway can also choose other color lines. Next, I will show you 3D navigation map. Now we need to collect room data. It is to control the car to move. So now let's control the car to move forward and run all over the room. Now the car is moving. In the middle of the room, here is the table. The front is a cabinet, and the side is glass. Then use this box to block the bottom. If the viewing angle is farther away, its recording effect will be better. If the viewing angle is too low, then its market angle will be relatively low. We are finally going to re-enter this table. Well, this is the center, and then the line of sight can be adjusted from here to here. The table is almost ready now. Come back here, and turn around again, then the model of the whole table will come out. Now we have almost created it. We can save this map, and then try this navigation. Now the 3D map is loaded successfully. Here is the table, and here is the bookcase in front. And here can be adjusted according to the actual situation. Now we can start to navigate. The robot will keep looping back and forth in the points I selected. So the demo of the navigation is here. Now let's experience one of the cases, visual face recognition. Now the first person is in the center of the screen. Let's come in another one. It can recognize multiple faces at once. This is one of its actual effects. We recorded these data in advance, so it will recognize faces according to each different facial features. Our evaluation is now complete, and now I will summarize it for you. This car is very rich in terms of functional gameplay and courses. There are not only online courses, but also practical courses provided by the company. The combination of theory and practice. You can get started with OS with zero foundation, and the official provides multiple configurations for you to choose from. If you want cost effectiveness and want to learn OS at a low cost, then this configuration is recommended. The Lidar equipped on it can be very good to complete some functions such as map building and navigation. In addition, it also has the depth camera configuration of OBI Shandong. This configuration can complete the combination of depth camera and radar, complete camera calibration, 3D navigation and mapping, etc. If you want to learn MoveIt manipulator simulation, you can choose the configuration with manipulator. If you don't have a display at home and need to debug, you can choose this configuration with a 7-inch screen. This configuration is equipped with a 7-inch screen. It is very convenient to debug. It is very suitable for outdoor demonstrations, or it is very convenient to carry on business trips. For this aviation aluminum box, its packaging is to use this box. But we can also use this box for storage and carrying, even if your car is fully assembled. It can be put into this storage box very well. Then lock it. If we want to go out and carry it to demonstrate outside, it is also very convenient to carry it by hand. The above is the whole content of this evaluation. Thank you for watching.